All right, let's do another one. Number 3. Determine the intervals of continuity for, you ready for it? It's awesome. F of x equals, not in Kansas anymore, x squared plus 1, 5, x plus 1. For x being all values less than 1, x equaling 1, and x being greater than 1. Ha ha ha. Isn't that great? Doesn't that just look awesome? That's a great question. Sure. So someone in my studio audience wants to try it. So, yeah. Oh, not on the record. Okay. Okay. So actually, I'm running out of time, so I'm going to go through it. But let's take a look. Determine the interval. So I'm looking at the concavity of this entire thing. I'm not looking at it at just a point. Notice how different this question becomes if all of a sudden I say, examine the continuity at x equals 1. Notice how different that question is, because this says I only have to worry about where x equals 1. In which case, this is a polynomial function. It's continuous everywhere. It's defined. This one's continuous everywhere. This one's continuous everywhere. So the only place that I'm worried about is where they match up. So really, the only question I'm asking, is the function defined at x equals 1? And it definitely is. There's the defining statement. So now the only question is, do they all match up? That's the only thing that's left to decide here. Very different question. We can use that information in what we're doing. We can take a look and we can realize that x squared plus 1 is a polynomial function. So it is continuous on negative infinity up to infinity. 5 is also a polynomial function, and it's continuous everywhere. And the same is true for x plus 1. This is just the same argument I gave you. So all of them are polynomial functions, so they are continuous everywhere. So the only question is, what's going on at x equals 1? That's the only question here. Okay, so to be continuous at a point, let's remember our definition. It's always good to write this out once in a while. Know what it means. So condition 1, we have to have a left-hand limit. Does it exist? And at this point, that's a question. It's not a statement. So for our limit, our two-sided limit to exist, there's a couple of things that have to happen for our two-sided limit to exist. First thing that has to happen is our left-hand side of f of x needs to exist, and it needs to equal a value that equals the same as our right-handed limit. So I guess we should take a look at that. So my left-handed limit is going to be the limit as x approaches 1 from the left, and it's x squared plus 1. I can use my mega property because this is just the left-handed limit, so I'm going to plug in 1, and I'm going to get 1 squared is 2. And the right side is going to be the limit as x approaches 1 from the right, and it's going to be x plus 1. Mega property, plug it in, and I get 2. So according to the mega property and everything else, we now know that the limit as x approaches 1 from the left of f of x equals 2, which equals the limit as x approaches 1 from the right of f of x, which is by definition what you can't see anymore. By definition, what you need for the limit to exist. And not only do I know it exists, I also know that it equals 2, but I don't really care about that right now. All I care about is, yes, it does exist. The fact that it equals 2 will become important later on. So, good news, it exists. Second question, second condition. is f of x defined at x equals 1? And the truth of that is, if I got to bring this out, the truth of that is that's answered right here. It's 5. Now, the fact that it's 5, nobody really cares. The fact that there's somewhere to be. Now, it is 5, and you're absolutely right. So, yes, it is defined when f of 5, f of 1 equals 5. So, yes, it equals 5, and that's wonderful. But more importantly, there's something there. Whether it's 5 or 7 or 12 or whatever it is, it's there. So now the third one is, so do they meet? Are they matching up? And that, unfortunately, is a little bit sad because the limit of f of x is 2, and the f of 1 is 5, which means the limit as x approaches 1 of f of x does not equal f of 1, which by definition means, therefore, the function f of x is discontinuous at x equals 1. And you need to be careful here because a math teacher could be really, really, really nasty here, and they could go back to the original question, and it says, determine the intervals of concavity. You didn't tell me the intervals of concavity. You told me where it's not concavity. What am I doing? Continuity. The intervals of continuity. Concavity is something that we'll talk about in a week or two. And so the intervals of continuity is going to be this one. So f of x is continuous on those. And I'm going to stop there, and I'll see if I have another example.